Assalamu alaikum everyone. This is lecture 3 for CS 116 object oriented programming. So let's begin. Now this is what we discussed in the last lecture. We discussed what objects and classes are. So if you want to define your own type of objects, for that you'll have to write some code that is called a class, and in a class you keep the attributes and methods together, and then if you want to use that class, you instantiate objects of that class, and you can always instantiate as many objects as you want. They all share the same class, or you can say they are all similar objects, but they are entirely different entities and they do not interfere with each other. Then we discussed that object-oriented programming paradigm has four main features: encapsulation and data hiding, inheritance, polymorphism, and association. And out of these four only, we discussed the first one only. Encapsulation and data hiding means that we are placing attributes and methods in a single object, and an object can hide whatever it wants from the outside world. In today's session, we'll discuss the next two very interesting features: inheritance and polymorphism. Now, inheritance allows reusability of classes. One of the most powerful feature of object-oriented programming paradigm is that it allows us to reuse existing codes. For example, if somebody has written a class, has defined a class, I can use the same class without any modification, and I can extend its functionality. Like I don't have to make any changes to the basic functionality of that class, and inheritance provides me a way to extend that functionality. So if I am writing another class which inherits from an existing class, then my new class will have access to almost all the attributes and methods of that existing class, and then I can define my new attributes and methods also, which will extend the functionality of that existing class. Now let's have a look at a small set of terminologies used with inheritance. If a class inherits from another class, then the inheriting class is called the child class, and the class from which this child class is inheriting is called its parent class. Or you can use that blue pair subclass or superclass, or you can use that third green pair derived class and base class, right? Now at this point, let me make you recall the three access specifiers: public, private, and protected. At that time, by public, I meant that if an attribute or a method is public, then it is accessible from everywhere, from within the class and from the outside world, right? Whereas if it is a private variable, private attribute or a private method, then it is accessible from within the class only and not from the outside environment. At that time, by outside environment, I meant the main code, right? Now I want to add another environment here: child class or child classes. So let me redefine these three access specifiers for you now. If a method or an attribute is public, then it is accessible from the main class. It is also accessible from the child class or classes, and it is also accessible from the main program, right? If an attribute or a method is private, then it is accessible only from within the class. Child class or classes and the main program cannot access it. Now, for protected, if an attribute or a method is protected, then it is accessible from within the class, from where they are defined, or from where it is defined, and also from the child class and classes, but they are not accessible from the main program. Now, this table summarizes what I have just told you. Attributes and methods which are defined in a particular class, let's suppose a parent class, they are accessible from this class, whether they are defined public, private, or protected. For child classes can only access the public and protected attributes and methods of its parent class, right? Whereas for the main program, you can only access the public attributes or public attributes or methods. Actually, only the interface is visible to the main program. Now, the power of inheritance lies in its abstraction. By abstraction, I mean that we can build hierarchies using inheritance. Like you can organize your classes in a hierarchy, right? And that's a very good way of organizing a large code. Um the upcoming examples, they'll make you understand this hierarchical concept in a better way. Is a relationship? This too we'll discuss in the upcoming examples. Example 1, the living things hierarchy. Now, again, this is a metaphoric example, but you'll see shortly that this will help you understand the concept in an excellent manner. Assume that all the variables and methods that I'll be defining in this example, they are all public. Now, let me define my first class. I'm calling it living thing. Now, this class living thing, as you can see, has one attribute lifespan, because every living thing has a specific lifespan or age. Similarly, all living things they exhibit these two functionalities. Every living thing can breathe, and every living thing can grow. Now, this is my main class, base class, or the parent class. Using this class, I'm defining two more classes. Actually, I'm inheriting two more classes from this class living thing, from this parent class living thing. One child class is called animal and the other child class is called plant. Now, in animal, I'm adding an attribute eye color and a method move. Now, since it's a child class of living thing, that means that this child class animal, it has access to its own attributes and methods, as well as it has access to all the attributes and methods of its parent class as well, like of living thing as well. Similarly, plant, in this class, I'm defining an attribute stem type, and I'm adding a behavior make food. Right now, see, we have three classes here at hand, and I can instantiate objects of any of these three classes. Now, let's suppose I am instantiating an object of the class living thing. Then that object can access only the attributes and methods of this particular class living thing, because the idea is that that this class parent class has been defined before the definition of its child classes. So it doesn't know anything about its child classes. So it can only access attributes and methods of its own class. But for animal and plant, since they are inheriting from living thing, any object defined for animal, it can access eye color, the function or the method move, and it can also access the attributes and methods of its parent class living thing, lifespan, breathe, and grow. So an animal can move, it can breathe, and it can grow, and it can have two attributes, eye color and lifespan. Similarly, for plant, since again it's a child class for living thing, then a plant object, it can have a stem type, and it can have a lifespan, and it can exhibit functionalities like make food, breathe, as well as grow. Now, let's extend these child classes further. Let me define two more classes which are inheriting from this class plant, shrubs and trees. Now, as you can see, in shrubs, I have added an attribute shrub type, and it can perform an extra functionality of making medicine. Whereas in tree, I have included wood type, and I have added a functionality of making furniture, right? Similarly, I can extend this class animal. And let's suppose I am making these two child classes, fish and birds. Fish has scales and it can swim, and birds, they have a beak type and they can flap their wings. Right now, you see, this hierarchy now comprises of three layers. The first layer is the parent class, the living thing. The second layer contains two classes, animal class and plant class. And the third layer, it contains four classes, fish, birds, shrubs, and trees. And in a hierarchy, this third class, it can access attributes and methods of layer 2 as well as layer 1. That means a fish can have scales, it can have an eye color, and it can have a lifespan. And a fish can swim, it can move, it can breathe, and it can grow. Right? Now let's add a fourth layer to this hierarchy. Now I am deriving two more classes from birds, penguins and parrots. For penguins, for each of these two classes, you can see that I have defined some distinguishing set of attributes and behaviors, right? So penguins, they can be differentiated by height, by their heights, right? And penguins can swim, although all birds cannot swim, but penguins can swim. Similarly, for parrots, I have declared an attribute origin, and I have declared a method called talk, right? Parrots can talk, right? Now I want you to appreciate something here, that the attributes and methods, where you place them, in which layer or in which class, that's a design decision. Like, it's up to programmer how he defines a class. For example, if you see this attribute of parrot's origin, I could have placed this attribute in living things also, because every living thing has an origin, right? So but since I was not able to find any distinguishing attribute for parrot, so I just put it here. But again, it can be placed in any of these classes, in any layer, right? Because every living thing can have this particular attribute. Similarly, if you see that method in penguins swim, this method exists in the class fish also, right? So again, it was my design choice that I am placing this function like this. A third person or you could have designed this hierarchy in an entirely different way, right? So the point that I'm trying to make here is that where you put a specific attribute or where you place a specific method, that's a design decision, right? Now let me add just one more layer. I'm deriving a child class called macaw from the class parrots, right? And I could not think of any distinguishing method for this new class macaw, but we all know that there is a variety of macaws and they all have different colored feathers. So this is the fifth layer that I have added to this hierarchy. I think now these 5 layers are enough. Now let's instantiate some objects. The first object that I am defining here or instantiating here is of class penguins. Okay, this is my object. It's called Skipper. And Skipper is a penguin from Madagascar. And as we have discussed before also, that this Skipper, since it's an object of class penguins, that means that it can have access to these two attribute, this attribute and method of class penguins, height and swim, and it has access to all the attributes and methods of its parent classes in the hierarchy. So see, this is the hierarchy. That means that I can define height for Skipper. Here I have defined it to 90 centimeter. I can define a beak type for it, and I can define an eye color, let's say brown, and I can also define a lifespan for this this object, right? And this Skipper, it can swim, it can flap wings, it can move, it can breathe, and it can grow. Now our second object for this example is another movie star called Blue from Brazilian rainforest. And as you can see that this is an object of class macaw. That means that it can have a color which is blue. It can have origin from class parrots, and I have defined it to be Brazil. It has a sickle-shaped beak, and it has its eyes are black, and it has a lifespan of 50 years. Now, I hope you are able to track the hierarchy by yourselves for this second object. The last object that I am defining here is of class trees. And this is the object. So this is not some movie hero, but it's kind of a real life hero. I'm naming it Oak Tree. And Oak Tree can have a wood type, which is oak here, stem type, which is woody here, and it can have a lifespan of 300 years. Now, let me show you why we call inheritance is a relationship. Now, consider this class penguins. Now, this penguin is a bird. Just look at the direction of the arrow. So, since penguin is the child class of this class bird, I can say that penguin is a bird. Similarly, I can say bird is a animal or is an animal, right? And likewise, animal is a living thing. And you can also say that penguin is a living thing or penguin is an animal, right? So that's why inheritance is called is a relationship. Now I just want to add one more thing here, one more concept here actually. uh, this is a hierarchy of classes, right? Now if you see this hierarchy from bottom to top, in fact in this case if you see this hierarchy from right to left, you'll see the concept of generalization here. That means that penguins and parrots, they are generally animals, or you can say penguins, parrots and trees, they can all generally be called living things, right? Similarly, if you go from left to right, that is if you go down the hierarchy, this is called specialization. Like penguins or macaws, they are special types of living things, or trees, they are special types of living thing. Now this second example is a more practical real world example. Humans of entity, we know that different kinds of people, they are associated with our university. Therefore I'm defining the base class as person. Now this class has two attributes, name and gender, and for simplicity I have just defined the getter functions. Now I am deriving two subclasses from this main class. The first one is employee. An employee of this university can have an employee ID, uh, and a specific salary. And again, get employee ID and get salary, these are the getter functions for these attributes. The second class that I'm defining here is for you guys, student, and a student can be associated with some specific department. Now let's extend this further. Now I'm deriving two subclasses from the class student. A student could be an undergraduate student, or he or she could be a graduate student of PhD or masters. So for undergraduate student, we have a specific batch. For example, you belong to batch 2019, and graduate student, he or she could be associated with some specific graduate program like PhD or masters, and then each department, they offer specialization in masters also. Similarly, let's extend this class employee to faculty and staff. Like there could be teaching faculty and then non-teaching staff, right? For faculty, we can define a position like professor or lecturer or any other position. And for staff, we have grades. Let's suppose we have grades. And then I am further classifying this faculty into two types: visiting faculty, which are hired on, for one semester or a couple of semesters only. And then we have regular employees or regular faculty. uh, and you can see here I have defined some specialized attributes through which I have tried to distinguish these two types of classes. So a faculty member, it could be he or she could be a visiting faculty member coming from outside just to teach a couple of courses in NAD, or he or she could be a full-time regular member of the university, right? Now let's instantiate an object of this class regular, right? Now I'm calling this object employee 1. Years of service 19, position is assistant professor, employee ID is given, salary is encrypted here, and that's me, and gender is female, right? Now let me define one more object, employee A. And employee A belongs to the class employee. Uh, as you can see, I have removed some of the classes from the lower portion of this slide just to clear the clutter, right? Now, since employee A belongs to class employee, which is in second layer, so that means that employee A can access attributes of only two classes, employee and person. So employee A can have an employee ID, salary, name, and gender, but employee A cannot access attributes of the classes preceding it, because as I said earlier, these classes, they are formed after employee. So employee can only access attributes of its own class and its parent class, not its child classes. Now, this is a related concept, Multiple inheritance means that a class is allowed to inherit from more than one superclasses. That means a child can have more than one parents, and in this case the child class will inherit all the attributes and methods of all its superclasses. Right, now let me show you an example. I am defining here a class called father having one attribute eye color, and here I define another class mother, fortunately or unfortunately having the same attribute name eye color. Now I derive a child class from both these classes. Now the problem in multiple inheritance is that if there exists an attribute or a method having same name in more than one parent, like here in this case, then the question arises that which method or attribute will the child inherit. Like in this case the question is which eye color will the child have, right? Now the programming languages that support multiple inheritance, they must provide some way to decide that which of the eye color will this child inherit. Like they all define a pre-decided order which determines inheritance of such a child which is inheriting from more than one parent. Therefore this feature is usually discouraged in some programming languages. Like Java doesn't support multiple inheritance, but Python and C++ do. Now let me show you another quick example. Let's suppose I have a class employee having two attributes, name and employee ID. I inherit three subclasses from this class employee: manager, regular employee, and security staff, each having its own set of attributes. And then I define another independent class person with name and address, and I derive two subclasses from this, man and woman. And now I add a third layer. I derive a class Salman, and Salman is a man and a regular employee. Now I want you guys to think over this. Like I want you to list the attributes that Salman can access. So you just think over it, and then we'll discuss this in the upcoming live session. Now let's discuss the second big OOP concept for today, polymorphism. Polymorphism is a Greek word and it means appearing in different forms or in different shapes. Now let me give you a general example on this. Let's suppose I'm in quarantine and I want to talk to any of my friends. So the best resource that we all have nowadays for communication is a cell phone, right? So what I can do with my cell phone, I can send an email, which is a relatively slower method, or I could send a text message, or I could make a phone call, or I could even make a video call, right? Now you see, these are all different forms of communication. Approach is different in each case, but the goal is the same. So in this scenario, we can say that communication is polymorphic. Okay, now in computer programming, polymorphism, it refers to processing of objects differently depending on their data types and classes. Now by this I mean that an object or part of object, especially methods, they can be defined differently in a program. Like a single method can have more than one implementations, and we can use each of these implementations as per need. Same goes for the operators. For example, plus, minus, and other operators. We can use these operators in different ways depending on the types of operands we are offering. Now, one thing that I find really interesting in this scenario is that polymorphism in computer programming is itself polymorphic. Like there are multiple features in object-oriented programming that exhibit polymorphism. These are those three features: operator overloading, method overloading, and method overriding. Now we'll see each one of these in detail. Now, operator overloading is the easiest of the three concepts, easiest to understand. Operator overloading, as I just told you, means that we can use the same operator in different ways. And this concept is not actually related or tied only to object-oriented programming paradigm. We had been using this concept in the last semester too. So just let me make you see that. This is a Python example. Look at this operation. 8 plus 3, it gives us 11. And we have been using such operations very frequently in Python. Now, here, if you see, plus operator is used for arithmetic addition, like this statement shows. But we have been using this operator in other forms too. Like, consider this example. Here, this plus operator is not arithmetically adding these strings. Actually, it is concatenating these three strings: hello, that space, and word. So now here you can see that plus operator is overloaded. Like, it is performing different operations depending on the types of operand we are providing it. This is another example. Here we are concatenating lists using the same operator. What about this? Can we do this in Python? Try executing this statement in Python and you'll get an error. You'll get a syntactic error. But if you know how to overload operators, how to write code for overloading operators, you can surely implement this, and this could result in some kind of, string plus integer concatenation, which is currently not allowed in Python, but you can always overload this operator to implement this. One problem is that operator overloading can be confusing at times. For example, somebody can implement subtraction under plus sign. Like here in this first example, 8 plus 3, you are writing 8 plus 3 and you are getting the answer 5. That means somebody has written that subtraction code for this plus operator, right? Now, this is the reason the designer of some languages think that this feature is more of a problem than it is worth. Java is one such language. Although Java provides overloading by itself, but it does not allow the users of Java to do so. Like, programmers cannot overload any operator. So while using this feature, one must take care by documenting and commenting properly to avoid any confusions. Now let's discuss method overloading. Method overloading is similar to operator overloading, just applied to methods instead of operators. So method overloading means that we can define more than one methods, and they all can have same method name, but they are differentiated on the basis of their arguments or parameters that we pass to them. Now, this basically extends the functionality of a method or behavior of a method. We'll see that shortly in the upcoming examples. One more point here is this, that just like operator overloading, this concept again is not restricted to object-oriented programming paradigm only. Like, you can use method overloading in your procedural code as well. Example 1 is of C++ code. Now, why I'm taking example of C++ code and not Python, you will know that shortly. This is the code. Since the syntax is different from Python, so let me explain that to you a little bit. In Python, what happens when you define an object, Python automatically detects its data type. Like, if you are writing 5, then Python assumes that it's an integer, and if you are writing 5.6, Python assumes that it's a float value. And in Python, you have the liberty to change the data type whenever you want. Like, if you are writing a is equals to 5 and later you make it a is equals to abc, that's absolutely fine in Python. But that is not the case with other languages. So in C++, what happens, you have to explicitly define the type of a variable. Like here, if you see in this example, actually this is a function definition. They do not use that keyword def here. So multiply is the name of the function, right? And in round brackets you are passing two parameters. Now, if you see here, it's written integer a and integer b. That means that C++ is restricting you, or the programmer is restricting you, to pass integer arguments only. You cannot pass float or any other type of arguments here. These arguments or parameters, they must be integers, right? Similarly, the first value written the first term written before this multiply, int, that specifies the return type. This means that this function can only return integer type value. It cannot return any other type, float or string, to the calling program. And the implementation is simple. It returns a into b. That means a and b are integers, and it will multiply those two integers, and the integer result will be returned to the calling program. Now, let's suppose I want to use this the same method or same function to multiply two floats. then this implementation cannot be used. I'll have to write another implementation. And since method overloading is there, so I can write this implementation. Now this is the overloaded version of this same function multiply, and now you can see we are passing different type of arguments here, float type arguments, and the return type is also float. So this is method overloading, like we are using the same function but it is using different types of parameter. This could be another implementation. Here the number of arguments is also different. We are passing just one float argument, and that float argument will be multiplied by 10, and then the result will be sent back to the calling program, right? Now if you recall Python, the first two implementations, you do not have to write different code for these two implementations. So this is the Python code. This works for integer and this will work for floats as well. So you do not have to overload this method luckily in Python to provide different implementations, right? Example 2 is from Python. Consider this code. This is the same code that I used on the last slide. Now there we saw that this code is enough to be used for both types of parameters. You can pass integer parameters to it, or you can pass float parameters to it, or you can even pass one integer and one float parameter to this, right? And Python will not raise any error and this will work perfectly fine. What about the third implementation that we saw on the last slide where we were multiplying a by 10? So that won't be possible here. So for that I'll have to write this method again. So let's try overloading this method, and this is the second implementation that I provide here. I'm passing just one argument a, it could be integer or it could be float, and it returns a multiplied by 10. Now my question here is that will this implementation work in Python? I want you guys to think over this, and then we'll discuss this point in the upcoming live session. Now lastly, let us see what method overriding is. Method overriding means that we can have two methods and having the same name and exactly same parameter list. The only difference between those methods will be in implementation. Now if you compare this with method overloading, there we had same method name but different parameters, and implementation it could be same or it could be different, but here the parameter list must be same too, right? Now this concept is tightly coupled to inheritance. Unlike operator overloading and method overloading, those concepts they could be implemented in procedural languages also. So we did not need inheritance or object oriented structure for that. But here this concept relies on the concept of inheritance. That means it is implemented only in object oriented programming paradigm, right? Now by this I mean that when you are overriding a method, both cannot belong to the same class. Let's suppose if a method is overriding another method, then the overriding method has to be in the child class, whereas the overridden method has to be in the parent class. So they both belong to different classes. This changes the existing behavior of a method, and we'll see examples of this shortly. And this last point I've already covered. In this example, we are considering two classes, class A and class B. Class A is the superclass or the parent class, and class B is the child class or subclass inheriting from class A, right? Now, we'll consider three scenarios, and each of them we'll be instantiating an object called obj1 of class B or object1 of class B, and in each case you'll see that there is a method called method1, and obj1 will be invoking this method. So this is the first case. This is the scenario that we just defined, class B inheriting from class A, and in this scenario method 1 has been declared and defined in class B. Now if you call this method through that object obj1, then obviously since there is only one implementation of method 1 and that is in class B, so this method will be called. This is case 2. In case 2, the same method has been defined in class A and it does not exist in the child class or class B. Now if obj1 calls this method method1, your machine will first search class B for its implementation. But since it's not there, then it will go to the parent class class A, and there it is, method 1 is there. So method 1 of class A will be executed, right? So the point here is that your machine will always start searching from the child class or the class of which the object is. Like I said that obj1 is an object of class B, so it will be searched in class B first, and if the machine doesn't find it there, then it will go to the upper hierarchy, right? Now this is the third case. In this case, we are defining the same method in both the classes. So as per our rule, when obj1 calls method 1, which method will be called? Obviously of class B, because your machine will start searching for this method, for this particular method in class B first, because obj1 belongs to class B, right? And since it finds it there, so this method 1 of class B will be executed, right? We can say that method 1 of class B in this case is overriding method 1 of class A, right? So here exist two implementations of the same method, but method B will be executed and implementation of method 1 will be ignored. Why we need method overriding? For that, let's consider another example. I'm defining here a class called shape, and I'm defining a single method called find area here. And this method find area, it takes two parameters, d1 and d2. Basically by d1 and d2 I mean two dimensions. I'm not explicitly defining any attributes here, and I'm just passing the parameters directly to this method just for simplicity, right? You can have any implementation that you feel like, right? Now let's suppose I want to implement this method. So this could be one possible implementation of this method. Like the simplest formula that comes to my mind is that I just multiply the two dimensions and I'll get the area, right? Now let me derive a child class from this class shape, rectangle. Assume that this find area method has not been defined in this class rectangle. So if I instantiate an object of this class rectangle and I try to invoke this method find area, what will happen? Since your machine will not find that method in class rectangle, so it will go to its parent class, and this already defined find area method will be called. Now this implementation works absolutely fine for a rectangle, because you can simply pass the two parameters of rectangle, length and breadth, and it will simply return me length multiplied by breadth, right? Similarly, if I inherit another class here, let's suppose a square. Now this implementation will not directly work for square, but we can make it work. For example, if L is the length of each side of square, then I can simply pass that length in D1 as well as in D2. So that will return to me L multiplied by L, and that will give me area of that square. So that means that I can make the same implementation work for square as well. Now let's suppose I want to inherit a third class from this class shape, a right triangle, right? Now for right triangle, if you want to calculate area for a right triangle, then again you will be needing two dimensions, height and base. So the definition of the function seems fine. D1 can be equal to height and D2 can be equal to base. But the problem here is that formula for calculating area of a right triangle is different from this given implementation. For that we write height multiplied by base divided by 2, right? So that means for a right triangle, this implementation of find area method will not work. So what I can do, I can just override this method in this class. So I am defining or overriding this method find area in right triangle class. So if an object of this class right triangle is instantiated and this method is invoked, then since base class, not base class, the current class will be searched first. So find area method of right triangle class will be executed. Same is the case with circle. Let's suppose I inherit another class called circle. The same problem exists there. Circle, finding area of circle requires a different formula. And now since we have given overriding implementations for these functions in these two subclasses, right triangle and circle, we can define them differently. This is the possible implementation for finding area of right triangle. I have tweaked the formula to d1 into d2 divided by 2. So d1, if d1 equals to height and d2 equals to base, this will compute the area correctly. Now for circle, there are two problems. First of all, that calculation of circle requires only one parameter, that is radius, and again the implementation is different too. So in method overriding, I cannot change the order or the number of parameters, so I'll have to work with d1 and in d2, and there I can pass r multiple times, right? Like d1 is equals to r and d2 is also equals to r, and then I'll be able to find this 3.14 into d1 that means this is actually pi r square, or you can write 3.14 into d1 into d2, that will give you the same result, right? Now this example, I hope I'm able to clear why we require method overriding, and this is one of the most powerful features that polymorphism or object oriented programming paradigm provides. This is a related concept, abstract methods. Uh, what are abstract methods? Abstract method is a method that is declared in a class, but it contains no implementation. Like you just define that method, that first line that you write for defining a method, but you do not write any implementation for that method. Such methods, they are called abstract methods. And if a class contains an abstract method, then that class itself becomes an abstract class. And what's an abstract class? Basically, you cannot instantiate any object of such a class, of an abstract class, because objects, they are concrete, and if you want to instantiate an object, then the class should have implementation for all the methods. Now if you want to use this abstract class, what will you do? You'll have to define a child class inheriting from this abstract class, and that child class must provide implementation for all the abstract methods of its parent class, and then you can instantiate objects of that child class and you can use them. Abstract methods cannot be private because private methods, they are not accessible from child class. So an abstract method has to be either protected or public, but it cannot be a private method. Now, what's the use? We usually use this abstract method technique for standardization. Like if you define a method abstract in a parent class, then you can enforce all its inheriting classes to implement that method. It's like that if I ask all of you to bring laptops in class, so I'm enforcing you to bring the laptop, but I'm not enforcing you all to bring the same brand. You can bring any brand that you have, but the standardization is that you all have to bring laptop in class. Okay, now let's quickly revisit that same example of shape. Now I am defining this method find area as an abstract method. This italics means that it is an abstract method and I'm not giving any implementation for this. So all the inheriting classes, they must implement this method in their own ways. Like each one of them can have a different implementation. That's it for today. We discussed inheritance and polymorphism today, and these are the main takeaway points from today's lecture. Just pause the slide and go through them. They'll help you summarize the whole thing. Thank you.